All right, this is problem number 6 from the 7th assignment of the Calculus BC Winter Break packet.
So in this problem, we're supposed to find the point on the parabola y squared is equal to 2x that is closest to the point 1, 4. I don't know about you, Mr. Falk, but this looks like an optimization problem to me.
I'd have to agree, John. See, what you have here is an optimization problem, and what we're specifically looking at is the distance formula, because we're looking at the distance between that point and the closest point on that curve. So we're going to be minimizing the distance formula.
And what is the distance formula again?
So what we got for the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared.
All right. And from what we know, we're trying to find the distance from the point 1, 4. So if we plug that into the distance formula, we get 1 minus x squared plus 4 minus y squared.
Now I have to say, there's something that I don't like about that equation.
What don't you like?
I don't like those two variables.
Neither do I. What do you think we should do, Mr. Falk?
I think we should try to make that two-variable equation into a one-variable equation.
All right. So should we substitute for x or substitute for y?
Well, you could do either, but I would recommend substituting in for x, because that way we won't have to deal with the square roots.
Good thinking. I like it. So if we substitute in for x, we get 1 minus y squared over 2 squared plus 4 minus y squared.
Gotta love those one-variable equations.
Just love them. So let's expand this. First squared was at 1 minus or plus 2 y squared over 2 minus plus. That's going to be y to the 4th over 4. That's first the outside and the inside, the last FOIL, plus 4 squared is 16, minus 4y, and then minus another 4y. That's minus 8y, minus y times minus y is going to be plus y squared. How does that look, Mr. Falk?
Looks pretty good. The one thing I would say is I think that would be a minus, because you have minus y squared over 2 times 1, and then you have that twice, so that's going to be a minus right there.
Good thinking. All right. Shall we go on?
Yes.
All right, let's combine like terms. So highest order, we have a y to the 4th over 4. And then we have, this is just y squared, and this y squared cancels with that y squared. So that's nothing. Minus 8y. And then plus 16 plus 1. I believe that's plus 17.
Mm-hmm.
All right. So when we optimize, we take the first derivative and find where the derivative is equal to 0, so that we can see where the original function, the distance function, which is now just of y.
Right, and in this case, even though we have a function that's under the square root, we can ignore the square root itself, because really we're just trying to minimize what's in the radicand itself.
Correct. So if we ignore that, we get y to the 4th over 4 minus 8y plus 17. I say we take the derivative of it. This is d of y. I say we take the derivative of this with respect to y.
Mm-hmm.
So that's going to be d prime of y. Bring down the 4. 4 over 4 is 1. Reduce, so that's y cubed minus 8, and then that's just 0.
Right, and so to me, that looks like a difference of cubes problem.
Well, we want to set it equal to 0.
Right, of course. So, when we're going to factor that down, we're going to have difference of cubes. So we're going to have y minus 2 times y squared, and I believe that's a
Plus 2y, I think.
Plus 2y. Yeah, plus 2y.
And then plus 4.
Yeah.
All right. This can never equal 0. Does not factor. It has no zeros. So the only thing we have left is that y minus 2 is equal to 0. If we add 2 to both sides, we get y is equal to 2. Should we make sure that that's a minimum and not a maximum?
I think we got to bring out the number line.
Let's bring out the number line. Okay, if we plug in something much bigger than 2, what do you get? Positive or negative?
Something pretty positive to me.
I think it's positive as well. Something less than 2, let's say negative 24.
I think you're going to get a negative there.
Me too. Negative, positive, that looks like a minimum. That's good. So if we have the y values equal to 2, we can say that 2 squared is equal to 2x. We get that from our limiting equation because it has to be a point on the parabola. So 4 is equal to 2x, divide each side by 2, x is equal to 2. Check my work there, Mr. Falk.
Looks good, looks good.
All right, so if we have the x value and the y value, that looks like the point 2, 2 to me. Good work.